Morning students. So this is the next video tutorial on the next chapter, that is lenses. In the previous chapter we have seen how light changes its direction when it moves from one transparent medium to another transparent medium. So here we have another refracting medium through which the light transfers, that is lens. So a lens is a transparent refracting medium with a spherical surface on one or both the sides. So a lens can have a curve in one side or in both the sides. Now there are two types of lens. One is said to be as convex lens and one is said to be as concave lens. But you note, convex lens is also known as converging lens, and whereas concave lens is also known as diverging lens. And we'll see so what are the different types of convex lens and what are the different types of concave lens. So convex lens. If a lens is thicker at its center and thinner at the edges, you see, it is thicker at the center and thinner at the edges. This is called biconvex lens. Okay, so it is also a refracting medium which has one or both the sides or both the surfaces are curved. So this is called biconvex. But if you draw just like this, then this is called planoconvex. That is convex in bulging in one side and plane in one side. And but here in biconvex both the sides are bulging. So therefore the center is thick and edges are thin. Next we have this shape. This is called concave convex. Okay, concave. So you see the nomenclature of the name is set as like this. If it is plane, here first we will say planoconvex, and first here it is in form of concave, that is cave shape, that is we say concave convex, and this is just biconvex. Similarly here you see for concave lens, if a lens is thinner at its center and thicker at its edges, so this is just an opposite of this convex lens. This is called biconcave, and similarly this shape, that is called planoconcave, and this shape you can say as convexoconcave. Okay. So these are the different types of concave lens and these are the different types of convex lens. Sometimes this convexoconcave and concaveconvex is looked at similar. So to make it different, we draw it like this. Okay, just this part we just extend it. So if you take one biconvex, now if we imagine to be a lens here, biconvex lens, and if we bisect this lens in form of prism, and if I place a source here, so light will be falling here on the lenses, right, and a particular part of this lens will act as a prism and light will get focus at a fixed point called F, that is focus. Okay, so you see each and every particle here, every part of this lens will act as a prism, and whenever a light falls here, it will just refract to a fixed point, that is focus. And similarly, if a light falls on here, it will focus here. Any light, if it falls at the center, then it will go straight. So here in the diagram, as it is in place of this prism, we have a square box, then it gets reflected at a fixed point called F. Okay, so this convex lens is considered to be as converging lens. So why it is said to be as converging lens? Because it converges a ray of light at a fixed point. That means whenever a light falls on a convex, that is biconvex lens, always it converges to a fixed point. Okay. But if any ray of light is going straight, then it will move straight only. That is, it is passing through optical center. So that is why we say that this convex lens to be as converging lens, because here it converges the ray of light. Now make sure whenever you are drawing the ray of light, there you have to draw the arrow. Arrow direction is must. Without the arrow direction, your diagram will not be completed. Okay, so we have to mention the arrow direction to indicate from where the light is traveling, from which direction to which direction. Next we have here biconcave. This is a biconcave. Now whenever a source is placed in front of this biconcave lens, always whenever light falls here, it tries to get diverged. Okay. Here always it is being seen that it is diverging from its position. Now if you produce back, this forms an image here. That is, focus is formed on the in front of that of concave lens. But in case of convex lens, we see that image is formed in the right hand side. That means the focus was in the right hand side. So this, for this, the concave lens is considered to be as diverging lens. Okay. So which lens is said to be as diverging lens? Concave lens. Why it is so? Because whenever a ray of light falls on the concave lens, it diverges from its original position. And whereas convex lens is considered to be as converging lens, because whenever a ray of light falls on a convex lens, it gets converges, it gets meet at a fixed point, that is at focus. So here this was the arrow, the light is falling here, but it gets converges in front. That we say that here it is getting diverged. So that is why it is called diverging lens. So this is the actual path of that light, but when it is produced, it forms a focus in backside, that is in front of this concave lens. So it forms a virtual image here. So what is the basic function of lens? It forms an image of a real object. So if I ask what is lens, then you will say that a lens is a refracting medium which has one or both the sides are curved. But what is the function of lens? Lens is used to form an image of a real object. So there are some related terms to lens. Now if I consider here two glass spheres. Now both the glass spheres are combined in such a way that it forms an intersection part here. This intersection part is considered to be as lens. If I draw like this, this is the intersection part. So this is the formation of lens by two glass spherical surface. If I say this one, that is the center, geometrical center of this lens, that is considered to be as O, that is called optical center. Okay, so what is optical center? The geometrical center of lens is called optical center. Now if we consider this sphere, let us consider that center 1, and for this sphere that is a center 2, right? So this center is called center of curvature. Okay, so what is center of curvature here? Center of curvature. Center of curvature means that is the center of the sphere of which lens is a part. So this is how we are going to define the center of curvature. Okay, next we have radius of curvature. Radius of curvature. You see, from the center to the optical center. That is, this one we consider to be as radius of curvature. That is the distance between center of curvature and optical center we consider to be as radius of curvature, that is denoted by capital R, where the center of curvature that is denoted by capital C and optical center that is of capital O. So you see, if I consider here this lens, this is a biconvex lens, it has optical center that is O. Now this sphere will have a center here over here, that is C1, and this surface will, if you complete the circle, then you will find the center 2 here, that is these are the center of curvature. Now the distance between O and C, that is C1, this distance is considered to be as radius of curvature, and this is also radius of curvature. Now an imaginary line drawn passing through center of curvature and optical center is considered to be as principal axis. Okay. That is a principal axis. Okay, so what is principal axis? The imaginary line that passes through center of curvature and optical center is called principal axis. Now when a ray of light is falling on this convex lens, if I consider this one, so let's draw here only. So if I consider this one as biconvex lens, when a light falls parallel to this convex lens, it will converge at a fixed point. That is called focus. Okay. So what is focus? Focus is a point on the principal axis where all the light meets after refracting from a lens. So after refracting means after passing through this lens, they converge at a fixed point, that is at focus. So this is the chapter, that is lens. I hope you have got your textbook, so you will refer in your home, or I will be giving a PDF files of this chapter which you will be writing in your exercise book. Okay. So what is lens? A lens is a transparent refractive medium with a spherical surface on one or both the sides. The same what we have discussed here. So these are the different types of converging lens, that is a convex lens, and these are the different types of diverging lens, that is a concave lens. Also we have learned how the light converges and how the light gets diverged. So when light falls here, the different parts of this lens, you see a convex lens is being bisected and it forms a prism. Okay, that means five parts you see here. So when light falls on this prism, it converges here. So that is why this is called converging lens. But similarly here concave lens is called diverging lens, that is the light is getting diverged and the focus is formed in front of here. So it forms a virtual image and it forms a real image. That means convex lens forms a real image and concave lens forms a virtual image. This one you will remember. Okay, so the converging action of convex lens, you see it is converging here, and this is the diverging action of concave lens because it diverges the ray of light. Ray 1 is falling here and it goes away, but it is producing a focus in front of here. That means opposite to the direction of flow of ray. That is ray of light in which direction it is moving, it forms a focus in backward direction. Okay. Also we have seen some special terms related to the lenses, that is center of curvature, that is center of the sphere of which mirror that lens is a part, and radius of curvature, that is the radius of the sphere of which lens is a part, you can say, or you can say the distance between center of curvature and optical center. This is also correct. So optical center, geometrical center of a lens is called optical center, and principal focus. So whenever a ray of light is passing through the optical center, it will pass straight here, both in both the cases, whether it is converging lens or diverging lens. Whenever a ray of light is passing through optical center, it will move straight without any bending. Okay, here also you see whenever a ray of light, that is a black color ray, whenever a ray of light is passing through optical center, it is moving straight. Okay, that's what I was explaining in the board, that whenever a light is falling at the center, it will move straight, but if it is falling with some other angle, then it will get converged at focus in case of convex, and it will get diverged in case of concave. Okay, so these are the topics you will need to write in your exercise book. See, we have first focal point. So what is the meaning of first focal point? Let's see with the help of a diagram. In the diagram you see first ray of light is falling here parallel to the principal axis. So whenever a ray of light is passing parallel to the principal axis, they will meet at a fixed point called focus. So this F1, this is called focal point 1. Okay, similarly in case of concave, you see light is falling parallel here, or the light is falling here and it moves parallel, then the focus here in case of concave it is considered to be as focal point, that is the first focal point. So one thing you note in both the diagrams, when the ray of light is passing parallel, then it will meet at focus, or if a ray of light is passing through focus, then that will be parallel to principal axis. Okay, converse is also true. Here the light is, you see, falling on the concave lens, that is a diverging lens. They appear to meet at focus, so that therefore they are parallel to the principal axis. Okay, so these are some rules. That first rule says that whenever a ray of light is parallel to principal axis, they will meet at focus, and if a ray of light is passing through optical center, then it will move straight. That you see, it's moving straight. And if it is passing parallel to the principal axis, then they will meet at focus here. And in the third rule you can see here, when a ray of light is passing through focus, then that will be parallel to principal axis. They appear to meet at focus, that is why the ray of light are parallel to principal axis. Okay, so this is the first focal point of convex and concave, and this is the second focal point. Okay, so first focal point and the second focal point. In the first focal point you see the light is moving from focus and it is parallel to principal axis. The light is appears to meet at focus, but here in second focal point the light is falling on the convex lens and it is forming here focus. Okay, it is forming at focus. So in this video only this much. Here we have seen what are the lens, what is the function of lens, what are the different types of lens, and which lens is considered as converging lens, that is convex lens. Diverging lens means concave lens. Convex lens has 3 types. Convex lens also has 3 types. Both the convex and concave, they have three types of lenses, that is plano-convex, concavo-convex, or biconvex, right? So these are the types you will be noting down in your exercise book. And from the first chapter, that is the first chapter, already I have taken an online test, and this chapter also I am going to conduct an online test just after the completion of this chapter. So be prepared for that and start making notes in your exercise book.